Hi, today we're going to look at our last conic section, hyperbolas. And hyperbolas look a lot like our parabolas. In fact, they look like two parabolas going in opposite directions. This picture here would be a great example of a hyperbola. These two parabola-like shapes going in opposite directions of each other. And we actually have two types of hyperbolas. We have a horizontal hyperbola and a vertical hyperbola. Now, horizontal hyperbola, that's the one over here on the left, is going to open left and right. And a vertical hyperbola is going to open up and down. Let's first concentrate on the horizontal hyperbola, so the one over here on the left. Its equation is x squared over a squared minus y squared over b squared equals 1. Okay. Now, this equation, notice it's really similar to what we have for the ellipse. It's a minus sign instead of a plus sign. But we have an x squared over something minus y squared over a number. Okay. Now our vertices here, one here and one over here on the right, okay, are just like the vertices on our parabola. Okay, they're that inflection point where they change directions. So our vertices are plus or minus a comma 0. And we're also going to have foci, which the foci are still on that same axis, in this case the x-axis here. And it's going to be plus or minus c comma 0. And then we have these dotted lines here that are called asymptotes. Asymptotes are basically fences that our graph can't cross. So they kind of keep our graph in certain locations. In this instance, it forms this X, and so we can't go to the left or the right or cross over that. Okay, so our asymptotes here are y equals plus or minus b over a times x. These dotted lines are lines, so they're going to have slope. So they're in that y equals mx plus b format. And since it's crossing at the origin, that's why it's like plus 0. So we don't have to write that 0 for b. So asymptotes is y equals plus or minus b over a x. Hi, today we're going to look at our last conic section, hyperbolas. And our hyperbolas actually look a lot like two of our previous conic sections in different ways. First up, our hyperbola looks a lot like our parabolas. In fact, it looks like two parabolas. If you look at this picture here, these two black curves, that is a hyperbola. We need both of those to make an actual hyperbola. And the other way it's a lot like another conic section is the way its equation looks. Its equation looks a lot like our ellipse equation. So look here. These are the equations for hyperbolas. Okay. The difference between this equation and our ellipse equation is this time we're using a minus sign instead of a plus sign. With ellipses, we added those two fractions together. Here we're subtracting them. Now our hyperbolas can be broken into two types, horizontal and vertical hyperbolas. Now a horizontal hyperbola is going to open left and right, and a vertical hyperbola is going to open up and down. And you might be wondering, where do they get their names for being horizontal or vertical? Well, it comes down to which axis they're crossing. If you look at the horizontal hyperbolas, they're crossing the x-axis, which is your horizontal axis. If you look over at the right at your vertical hyperbola, it's crossing the y-axis, which is your vertical axis. I'm not going to worry too much about the transverse axis for right now. Let's look at our vertices. Okay, now our vertices are going to be on the same axis as our foci and the axis that our graph is crossing, our hyperbolas are crossing. Now notice on the horizontal hyperbola, it's crossing the x-axis, and A is in the x position, or the x value. On the vertical hyperbola, our curves are crossing the y-axis, so A is in the y position, or y coordinate. We also have foci when we're dealing with our hyperbolas. So our foci are going to be on that same axis as the vertex and the axis that's crossed by the hyperbolas. Our foci are plus or minus c comma 0 if you're on the horizontal hyperbola, and it's 0 plus or minus c if it's on a vertical hyperbola. And then you might notice it says c squared equals a squared plus b squared after those. Okay, so if you look down here at the bottom. Now, we did something similar with ellipses. With ellipses, it was c squared equals a squared minus b squared. This is an equation that helps us find our foci or our vertices or vice versa. It's the way to connect that original equation to the foci. And it's a plus instead of a minus this time. So it's a lot like what we did with Pythagorean theorem. It looks a lot like that Pythagorean theorem. Then we have something called asymptotes. Asymptotes are like a fence that your graph can't cross. So these asymptotes are keeping our parabolas or that hyperbolas in a certain position. So on a horizontal hyperbola, it's y equals plus or minus b over a x. And on our vertical hyperbola, it's y equals plus or minus a over bx. So you might be wondering why b over a is for one, a over b is for the other. Well, it comes down to the original equation that we're using for our hyperbolas. Now, if we look at our horizontal hyperbola here, it's x squared over a squared minus y squared over b squared equals 1. And for the vertical hyperbola, it's y squared over a squared minus x squared over b squared equals 1. Notice the order of x and y have changed between the two equations. Now, in both equations, the a squared is first, b squared is second. And now it comes back to slope too. Okay, with slope, it's always the change in y over the change in x. So it's your y value over your x value. So if you look down here at your equation for horizontal, the y value has b underneath of it. So b has to be in the numerator. X goes with a, so a has to be in your denominator, b over a. For the vertical hyperbola, now the a is underneath y, so a has to be in the numerator, which we have down here, and then b has to be in your denominator, so we get then the denominator. So really you want to look at where x and y are. That's going to tell you what's in the numerator, what's in the denominator of that slope. And keep in mind too, these are slightly different equations, whether it's horizontal or vertical. Notice we crossed the x-axis here, so x came first. On this we crossed the y-axis, so y goes first. So let's try an example of this. Okay, there's lots of stuff going on. Okay. So we have a hyperbola centered at 0, 0. It has vertices plus or minus 4, 0, and one focus, 5, 0. Now technically it does have another foci. Okay, that'll be negative 5, comma 0. So we have to change that sign. Okay. Now part A is, what is the standard form equation of the hyperbola? So we need to know whether it's x squared minus y squared or y squared minus x squared. And we can get that by just looking at our vertices. We have a number, a non-zero number in for x. So that means x squared has to go first. So if x squared minus y squared equals 1. And now we need those denominators too. Now our vertice is plus or minus 4, 0. So that's our a value. So 4 squared would go here. But we don't have b. We don't know what b is. And that's where that Pythagorean theorem, or c squared equals a squared minus b squared, comes into play. So I'm going to go ahead and do that work down here. So c squared equals a squared plus b squared. We just said that a is at plus or minus 4, so I'll have 4 squared here. I don't know what b squared is, that'll be b squared. And c goes with my focus. So we were told our focus is 5, 0, so c has to be 5. So here I'll have, 5 squared. Okay. Well, 5 squared is 25. 4 squared is 16. And we have our plus b squared. Now we need to get b squared by itself. So we have to subtract 16 from both sides. So when I do that, I'll have b squared equals 9. So b is going to be plus or minus 3. So if I go back up to my equation, I'll have plus or minus 3 squared, or I could just write 3 squared for this. Okay. Now I don't want to leave it with the 4 squared and the 3 squared for my final equation. I do want to actually square the numbers. So I have x squared over 16 minus y squared over 9 equals 1. That would be my standard form. So now we have to sketch the graph. Now when we sketch the graph, we're going to use this information given to us. Okay, so our vertices are plus or minus 4, 0. So that means I have to have a point at 4, 0. So I'll put my point there. Then I also need a point over there at -4. So I have my two vertices graphed, 4, 0 and -4, 0. Now, in order to get the right shape for our curves there, those parabola-like shapes, I'm going to need to know what the asymptotes are, or how to graph them. Now, I could use my equations up above to find those equations for the asymptotes, or there is a shortcut involving using that extra value we have, like the b squared value. So remember we had this 9, or that 3 squared. Well, that means part of this box or shape that we can't cross is by going up 3 or down 3. So I'm going to put little x's at +3 and -3 on the y-axis. Once I have the x's drawn, I'm going to use these 4 points to create a box. Now the box or the rectangle I'm creating is not going to have vertices at these 4 points. Instead, those points are going to be the mid value of that particular box, or each side of the box or rectangle. So let's go ahead and draw in those lines. So I went ahead and used the box function on my computer to draw that rectangle in. So your rectangle should look like this, where that midpoint of each side are the vertices or those opposite sides there. Our next step is to draw diagonals through this box. So let's go ahead and draw diagonals across the box. So now we have the diagonals drawn across the box. And the last step is to draw in those parabola shapes that make up the hyperbola. Now when we draw those in, we want to make sure that we're choosing our vertices here. So remember, this is the x squared came first, so it has to cross the x-axis. So I have to have it curve through here and curve through here. Now when you go to draw this, it can be difficult to draw. You just want to try to make sure that you don't touch these lines here. Remember, they're fences. They're keeping our hyperbola in place. So I'm going to go ahead and draw that in. Then I'm going to repeat for the other side. Okay. And so our hyperbola would look something like this. And I think I tried to choose ones on the Math Excel that they gave the graph and they needed to match it up with the equation, or vice versa, because it can be very difficult or tricky to draw these on a computer. So your assignment for today is up on Math Excel. So you want to take a few moments to work through those examples, try those out. They are due the following week on, let's see, I put the due date on there, so you should be able to look and see on the Math Excel what day it's due. If you have any questions or comments, go ahead and leave those on Google Classroom, or you can email me. Remember too that we have office hours 8 to 10 a.m. Monday through Friday, and you can also contact me during our Zoom meetings once per week. I will talk to you later. Bye.